Alright, we're going to go ahead and start where we left off yesterday. So we're on page 189. Now, yesterday with the few problems we had at the end, what was different about those, or what did we have to do differently to find our roots? Who remembers from yesterday?
Well, the graph only had two of the real roots, so the other two were imaginary. We had to find the factors of the constant and the leading coefficient.
Yeah, we could only see two on the graph, and we knew in the examples we did yesterday there should have been four, so we knew that two were real and two were imaginary. So we had to actually factor after we did the synthetic division and solve for those roots. Very good. All right, so we're going to continue on with that. It's basically going to be the same methods that we were using yesterday, but once we get to the end, there's going to be a little difference than yesterday. So let's start with the first one. We see that we have a function to the fourth power, and we want to graph this one, so you're going to need your calculator. Go ahead and graph this, and then we're going to put it on the coordinate plane they provide. That's similar to what your guys' graph looks like. Alright, so how many times do we see it actually touching or crossing the x-axis? Marie? Yeah, twice. Once right there, it's coming down, crosses over, and it's coming back up. So let's go ahead, draw that on our graph they provide us. So this first one looks like it's crossing really close to the x-axis, or y-axis, sorry. And then the other one looks like it's close to 1. Now, with our window, if you have your window from 5 to 5, or negative 5, the bottom of the graph is actually cut off. Now, with it cut off, we don't know where it's actually touching the y-axis, but if you look back at the original function at the top, where should this cross the y-axis? Yeah, if we look, the constant's negative 10, so this should actually be crossing at negative 10, so if you want to label that. Actually, more accurate representation would be like this. It's not its lowest point, but where it crosses. Its lowest point will be over here somewhere. So it crosses at negative 10. Alright, let's see what the next question has for us. So what conclusion can you make about the four roots of the function and explain your reasoning?
The function has a degree of 4, but f of x only shows 2 of the roots on the graph, so the other 2 roots are imaginary.
Okay, so 2 are imaginary. So what we can say, just to expand on that a little bit, you are exactly right. There is one positive real root, one negative real root, and there are 2 imaginary roots. So 1 positive, 1 negative, and 2 imaginary. Now, you guys could probably do this in your sleep by now, but let's list out the factors. So the constant terms on the top over the leading coefficient factors. Alright, so this one is going to have a big long list. So let's go ahead, list them all out. If there's any repeats, don't worry about writing the repeats, but there are going to be quite a few. Alright, so quite a few. So like we said yesterday and the day before, if we didn't have our graphing calculator, we would actually have to test every one of those, positive and negative. Luckily, we have the graphing calculator. So, from looking at the graph, if you want to look at your calculator or the one you drew on your paper, of all of these roots, which two of our real roots seem similar to one of these possible roots here? Which two do we want to check? Marie, give me one.
Positive 5, 6.
Alright, let's look. 5, 6 could be close. What else do we have? Because we have so many numbers. Let's see. Let me look at the actual graph here. What do you...
2/3.
Yeah, I'm thinking it looks a little closer to 2/3. If it was 5, 6, I think it would be a little closer to that. If you're looking at the actual one on the calculator, I think it looks a little closer to 2/3. So let's go with 2/3. And this other one may be a little tricky, but let's see. What do you think the other one is? Go ahead.
Negative 1/4.
Yeah, I think it's close to 1/4 also. If you look, if you did that 4 times, it looks like it's split up into about 4 sections. So negative 1/4. Now, if you're doing this, so let's say on a test or a quiz, and you pick one, let's say you did pick, which one did you say at first, Marie? 5, 6. If you picked that and did the synthetic division, and you got 0, yes, it would be a root, but if you did not get a remainder of 0, you know you would have to pick another one. So let's check these two to make sure they are correct. I'm going to start with negative 1/4. I know it's getting a little redundant, but you guys are going to be really good at this when it comes time to take the quiz or test. So the negative 1/4 did work. I'm going to use this answer again. Remember, it's easier if you use your answer, less terms, so I'm going to use this answer for the next one to check 2/3. And 2/3 also checks out, has a remainder of 0. Alright, so we just checked 2 of the roots. Our original function was to the power of what again? Power of 4. We found 2 roots, so after doing synthetic division twice, our polynomial is now a what? Quadratic. Yep. And just like yesterday, let's actually write out the quadratic. So we have 12x squared. We have an x this time, plus 24x. And then our constant plus 60 equal to 0. Now our goal here is try to get x by itself or try to factor it. So what do we see could be a good first step? Yeah, that's going to be the best option right now. Let's factor out a 12. It's going to make the problem look a little easier.
Can you leave the paper up?
Yeah, sorry.
Sorry.
No, you're good.
Thank you.
So we're going to factor out that 12. Now what can we do here to make this a little easier? And it's nice because we have it equal to 0, so what can we do? What's happening between this 12 and this group right here? Yeah, you can divide the 12 off by 0. Well, 0 divided by 12 is just 0, so it gets rid of the 12. So we're left with x squared plus 2x plus 5 equals 0 when you divide by 12. Now, the best possible case is we would be able to factor this right now. So go ahead and look at it, see if we can factor this quadratic. Any way to factor it? Anybody finding any way? So if we can't factor it, what other way can we solve a quadratic? Exactly. So let's go over here. So if it's not factorable, or you're not sure if it's factorable, try the quadratic formula. And what is the quadratic formula? Who remembers what that is? X is equal to what?
Negative b plus or minus the square root of 4ac plus b.
You're close. This is correct so far, and you know there is a 4ac in there and a b squared. But thank you.
Okay.
Yes?
B plus or minus the square root of b squared minus 4ac over 2a.
There it is. B squared minus 4ac all over 2a. You were close. So the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Well, now let's actually apply it to the problem and try to find our last two roots. Where do we find these b's and a's and c's at?
The formula we're trying to find the answer to, the constant would be c, the first number that has 3 would be a, and then one number would be b.
Alright, so we're actually using this function right here. So the first one, the b, is going to be the middle term, so the opposite of b, minus 2, plus or minus square root. So we have b squared. Well, negative 2 squared is just 4, so we're going to 4 minus 4 times ac. Well, the a is the coefficient in front of x squared, that's just 1. The c is the 5. That's all under the square root, all over 2 times a, well, a is just 1. Now we just have to simplify. I'm going to leave that negative 2 plus or minus out there. We'll simplify what's inside the square root. So what's inside the square root, what does that simplify to? So don't actually take the square root yet, but what does it simplify to, right?
Inside the square root, one that simplified to negative 16.
Yeah, very good. Square root of negative 16. On the bottom we just have 2. What does the square root of negative 16 simplify to?
4i.
Yeah, we're going to get 4i. Now we're almost there.
Which is simplify -2 into.
Yeah, we're going to pull out, well, we can't just simplify these two. What can we actually do to this whole problem right here?
We can divide the entire thing into 2.
Yeah, we can pull a 2 out of everything. So when you pull out the 2 of everything and they cancel, you're left with -1 plus or minus 2i. So how many roots do we actually have right here in this answer? 2. So we have the 2 from here, and we have the 2 that we checked up here with the synthetic division, and we should have 4 from the original, so that checks out. We have our 4 roots. So at the end of the problem, you would want to label the 4 roots are x equals -1/4, 2/3, -1 minus 2i, -1 plus 2i. So that would be your final answer. Any questions? Pretty much the same method. Once you're done with that, turn to the back. Anybody still using this page or copying? All right. So on the back, the first thing we want to do, we've done it so many times now, but we just want to express it in words so we have our steps laid out. So based on the results of the previous page, so the problem we just went through, we're going to provide a plan on how to find all the roots of a polynomial function. So what would be your first step? What would be the first step? We're going to try to get about 4 steps. So what would be our first step? Okay.
Graph it on the calculator.
Okay, we could graph it on the calculator. We can make that one the first one. Let's include with this one, what do we normally do when we graph it on the calculator? Okay. Now, what I was going to make step 1, we can make step 2. But what do you normally do before you graph?
You can find, oh wait, no, never mind. You do that using your rational.
Yeah, what were you going to say? I think you're right.
Well, like, if you were to put all the factors into constant terms.
Yes. So we want to make a list of all possible rational roots. So make a list of all possible rational roots. Now, like I said, we normally do that first, so if you want to label that as 1 and label the graph as 2, you can do that. But those are 2 of the steps. You want to make a list of all possible rational roots, and then when you graph it on the calculator, you find your possible roots from that list. Now in terms of just the last problem we did, so we're not thinking about necessarily the ones we started at the beginning, but the ones that we had to the power of 4, like on the previous page, what did we do next then? If you need to look back, you can look back. Yeah, we synthetically divide. By each of the highly possible roots to get the what? What do we end up with after we did the synthetic division? Yeah, we synthetically divide by each of the highly possible roots to get the quadratic equation. All right. And what would be our last step?
Would be to discover or find other roots.
Okay, you're on the right track. So solve the quadratic equation by doing what? We could do two possible things. I'm just going to abbreviate here. Solve by what? It's actually solve the quadratic equation by.
Well, you can either use the quadratic formula or you can actually just solve it.
Yeah, what did I say? What did I have you try before we used the quadratic formula? What did I ask you to try to do? Factor. So you can solve by factoring or using quadratic formula. That would be our fourth step. Solve the quadratic equation by factoring or using quadratic formula. All right, so the next two are pretty much like what we've done, so I'd like you to go ahead and try the first one. I am not necessarily going to put all of the stuff up on the board as you do it, but work through your steps. If you just want to view the graph on your calculator, that's okay. You don't have to draw the graph on your paper if you don't want to. You can just look on the calculator. But go ahead and try to solve the first one and find your three roots for that problem. Did you guys find a root through synthetic division yet? What was your root that you found, Anthony? Yep, so for the synthetic division, negative 2/3 is your root, so then you have to solve your quadratic. So go ahead and do that if you have not already. Because realize this is only to a power of 3, so after you do synthetic division once, you're left with the quadratic. Remember, if you can't factor, you have to use the quadratic formula. Was anybody able to factor this one? Let's see. You had x plus 3 and x minus 1? Okay, so if you have x plus... Let's look at it. You would have x squared. And you would get your 2x in the middle, but you would get negative 3 as your last term. So that can't work. Good try. So if we can't factor, you have to use quadratic formula. So go ahead and use that. Who was able to simplify the square root of negative 8? Go ahead.
You can move 2I out in front of the radical, but then you still have the square root of 2.
Yeah. So simplifying that, we would have negative 2 plus or minus. We would get 2I, and we'd be left with the square root of what? Yeah, square root of 2 inside, all divided by 2. Now the square root of negative 8, that can be written as the square root of 8 times the square root of negative 1, and then you can split up the square root of 8 to the square root of 2 times the square root of 4. That's why you can get the 2I out in front times the square root of 2. Now, what all do they have in common? What can we do to simplify? Yeah, we can get rid of the 2. So our final answer, 1 plus or minus I square roots of 2. So that's 2 of our roots. So then just at the end, wherever you have room, make sure that you write the roots are x equals negative 2/3, negative 1 plus I to the square root of 2 times the square root of 2, and negative 1 minus I times the square root of 2. So make sure you write that final answer and circle it. Those are your 3 roots at the end. Any questions on that problem? Feeling pretty good with it? Getting a little easier? Alright, once you're finished, go ahead and work on number 2. Again, if you don't want to draw the graph, you don't have to. You can just look on your calculator, but go ahead and work on number 2, please.
Excuse the interruption. At this time, I need those students going with Mr. Siegel on the field trip to report to the front lobby. Thank you.
I'm not going to show all the steps up here, but whenever you find 2 of the roots that work with synthetic division, let me know what they are, if somebody has found any yet. Did anybody find a root that works synthetic division yet? You found one, Mary? Did you test one already?
No,
Okay.
I was guessing.
All right. Well, test it and let me know if it does work. Did it work, Marie? All right, so your one real root was what?
3
X equals 3 halves, okay. Did anybody else find a different real root that worked with synthetic division? Three halves does work. Yeah. Yeah, negative 1/3. So if you didn't have those, go ahead, try those two roots, make sure they work. And after you finish the synthetic division, you'll have your quadratic left. Try to solve your quadratic. Quadratic you should be left with should be negative 6x squared minus 6x minus 6 equals 0. So when you get to that step, I didn't show all the steps, but that's what you should get when you get your quadratic. Negative 6x squared minus 6x minus 6 equals 0. Is anybody having trouble getting that, or are we okay with that? If you're having trouble, that's okay. Let me know, we can go over it. After simplifying that quadratic, what can you get it reduced to before you try to solve it? Marie?
X squared plus X plus 1.
Good. So after you simplify some, you should get the x squared plus x plus 1 equals 0. Can that be factored? No, so you have to go back to the quadratic formula. So once you get to that part, go ahead and use the quadratic formula again. Find the last two roots. All right, did anybody find the imaginary ones yet, or are we still solving? So right now I have this as the imaginary answers right now, but does anybody see another way I could break this up? Because nothing will cancel. Go ahead. Yeah, you can make that 3i. So we can make that, well, it'd be square root of 3i. Yes. I'm looking to do something else though. That's part of it. That definitely has to be done. That's part of it. Go ahead.
With the I square root of 2.
Not quite. We're not going to multiply by 2. Not quite. I think I hear something over here that sounds close. Yeah. So with this single term denominator, we can split this up. So we actually have negative 1/2 the plus or minus square root of 3 over 2i. You're technically right with this, but splitting this up, and then you can express your answer as negative 1/2 plus the square root of 3 over 2i, and then your other answer is negative 1/2 minus the square root of 3 over 2i. They both are technically correct. This is just a little more simplified. So then again, if you have room at the bottom, I don't have a lot of room here, write that your roots are x equals 3/2, negative 1/3, and then your two imaginary roots, and circle your final answer. Any questions? Feel like they're getting a little easier now that we've gone through them? All right, good job, guys. That's it for today.